Welcome, folks, for the first round of lightning talks. Lightning talks are really one of my favorite things. We had so many great ones last time, so I can't wait for these ones. Here are the rules. We have 9 amazing speakers who are going to do short presentations of 5 minutes each. Feel free during these talks and after these talks to type a question into the chat, so later they can interact with you in the chat. Then at the end of the lightning talks, we're going to have a round of open for all discussions and questions to all of these speakers. We're going to have a 5-minute limit. I'm going to ping you 30 seconds before your time is up. And we'll start with the first lightning talk, Ledeczi, by 3 new blocks in a world of possibilities.
All right, well, thank you very much. Let me start my timer. Actually, I lost my internet, so I'm coming through a phone, so hopefully it will work out. Anyway, so you can see my screen, right?
Yep.
And so this looks like Snap, right? Regular Snap, except for this network tab. So NetsBlox is an extension of Snap where we brought in networking capabilities. Okay, so there are really 3 main blocks that are kind of interesting: send message and receive message. Okay, and also this call. So let's start with call. So what is this call block? So we implemented something called remote procedure calls, or RPCs, which are basically functions that run on the NetsBlox server remotely, and you can get access to them. We also grouped similar ones into various groups called services. So for example, if I pick one particular service, then the second menu shows the available RPCs or functions. So for example, if I do this, it will show me a non-existent person. Let's switch the costume so that you can actually see that. Okay. All right, so this call returned an image. Now there are a bunch of other calls. So let's say under the climate thing, that is called Mauna Loa CO2 data. So that can display, let's say, the CO2 trend with these arguments. If I leave these are optional, so it will give me all the data that's available from 1958 till these days. So that's great. I can also do this. There's a built-in chart service using GNU plot, and so I can just draw that data immediately on the screen. So you see that it opens up a lot of possibilities. Now for showing the send and receive message, I actually created this distributed Hello World application. So these are 2 browser tabs. They could be running on 2 different computers under 2 different user accounts, and they would work the same. So this part, if I hit space, it will ask me for a message, and I can send it over to the other side, which displays it. Okay, so this opens up a whole lot of options for students to create distributed applications, social applications like chat room or texting, or distributed multiplayer games. All right, so these are the 3 blocks. Let me show a few slides just quickly. So just some examples of what you can do with RPCs, from visualizing COVID data to climate change data, or kind of implementing a geolocation search on a map, or displaying science data, in this case earthquake data on a map, having fun with movies, and lots of others. Okay, so some of the new things that I want to highlight: the latest one using the exact same abstractions, the exact same blocks, RPCs and message passing, plus a phone application called Phone IoT. It opens up the phone so that from a NetsBlox program, you can have access to all the sensors of the phone, and you can also display user interface elements and interact with those user interface elements. So unlike Catrobat, this is not an app development platform. The phone turns into a device that you can access from your program that runs in the browser on your computer. Okay, so this one is an exercise tracker. You can take your phone running while it tracks your location, displays it on a Google map, and then also updates the phone screen like that. Or this one just displays acceleration data on 3 axes as you move your phone around. All right. Another thing you can do is robotics. All kinds of Wi-Fi enabled devices are accessible again with the same RPC message passing combination. And we have done lots of interesting camps with that. The latest one is actually a Unity-based 3D virtual environment where you can connect and program these robots, and students can join remotely and have competitions and everything like that. All right, anyway. Lots of NetsBlox stuff is coming up this conference, so please check out this thing. First of all, we'll have a keynote on Sunday. This is a 5-minute version of the keynote. Unfortunate timing, but hopefully many of you can join and see what other things we can do with NetsBlox. Today there will be a talk with about text mining. There will be a workshop on how to do autograded assignment without leaving NetsBlox, or how to build your own Alexa skills in NetsBlox and integrate it either to a project or it could be a completely separate standalone Alexa skill. And then also Tom for Bird Brain will talk about remote robots and stuff like that. Anyway, I think my time is up, so thank you so much.
Whoa, that was great timing and an even greater talk. The NetsBlox is just so super cool. Snap on the browser and on devices and wonderful. So coming up is another talk about the real world. microBlocks meets physics presented by Andreas Gräfl from the University of Education at Heidelberg. Andreas, up to you.
Okay, can you hear me?
Yes, we can.
All right. Sorry, Jens, I'm using PowerPoint. Yes. Welcome that you're here. I try to make it quick. Yeah, my name is Andreas, and we had in the past like courses with students, and we start with the retrospect on Snap 2020, where we had the starter kit. I presented on last year, and now we had it, but there was still a problem because we can't use it because there was still like a Corona thing going on. So we started projects with students, not with pupils. And that's what they came up with. And that is one of the projects the students did. That was a free fall stand. So they made like a stand where they let drop something. And yeah, this was like physics meeting code and informatics, and we came up with issues. First of all, with the issues were that the cabling was quite difficult for even the students. And that's even with we also used schematics, but even then it was difficult for the students. And the second problem we had there were difficulties with libraries that were not included, for example, for this rotary encoder, which we then made our own, but still there were like the issues with finding in the internet. And we also heard stuff about that it's planned that all the things are in those codes and not that you're not searching around in the internet to find them. And what we came up with, that we don't use like the boxes with students because there was still the Corona issue. So we actually used the onboard sensors, and that's basically makes sense because you can do a lot of physics stuff with the inbuilt sensors. For example, this time temperature table we made, you can export the data, you can modify it in Excel, and you still do fun things, but don't have the cable issues. And upcoming, there are the next version of the microbit, which is used for those projects because it's compatible to microBlocks. And there are even more sensors on the board. which is perfect for us. And there are online courses for German pupils or for our project for Girls Digital Camps. And that's what we're heading, and that's what I'm presenting the next time then. So thank you very much, and I think I'm done. Yeah, Bernard, you have a question.
I wanted to clap, accidentally raised my hand.
Okay, thank you very much.
Andreas. Very cool microBlocks for coding, very much in line. So be sure to, I think you're giving a workshop, right?
No, I'm not doing a workshop, but our team is doing a workshop about something not on microBlocks, but on Snap.
Oh, on Snap, okay. So be sure to check them out. They're very cool, and they're kind of really cool friends over at the University of Education in Heidelberg. So coming up next is Glen, Rich Nguyen, and Joe Watts, University of Virginia, with this presentation about creating art through coding. Okay, over to you. Go.
Thanks. So are we sharing our screen?
We are now.
Might want to.
Hang on just a second. Okay, we have a link that we're going to put in the chat window that shows you all the examples. And so you can look at this at your leisure. On our desktop, though, we have an example of how we get from art to music. Not yet. So we started out introducing Snap in the context of art, and eventually in the second half of the semester, we then have them do music. And I wanted to have a 10-second clip of some of the projects they've done where they create their own musical instruments to sort of show you the end of the trajectory. So we're going to play that clip now. Hang on, we'll have to bring it over here. So we start out, we wind up doing things like that where they actually create their own musical instruments. In this case, they've actually wound their own solenoids and created 3D printed arms that they then, as you can see, program in Snap using Snap for Arduino to create a drum pattern. And they also make other kinds of musical instruments. But when they start, these are middle school girls. They have not had any coding at all in many cases. So we just start out with art. And we take them through various kinds of art you can emulate in Snap. And we're going to show you an example of Rothko. This is one of the students that emulated Rothko. And they're simply writing code to make bars and then positioning the sprites by hand and stamping the pattern. So there's a very low level of coding, but they do very creative things artistically. And it really gets them sort of engaged. Now, once they've kind of got an idea of what Snap is in this context, we then go on to do a Jason Pollock type art. And here's an example. Now, here essentially what the students are doing are randomly drawing lines and dots. This is a kind of a classic thing that people do in Snap. I want to show you a more advanced example of what one student did that really takes it a bit further. So we're just going to briefly run this one so you can see it. And here it's kind of like splatters of paint. And this is a little bit more sophisticated than the earlier example. One of the things that we've gotten recently that we like a lot is a gizmo that's made by Cricut. I can't see myself here. Okay, it's a gizmo made by Cricut that lets you take these patterns and put them on a cup. And this cost about $100. And we found that once the students create their impressionist, their design, they love to make cups and take them home for their families to have as a permanent example of what they've been doing in the project. The third example that we're going to show you involves creating an impressionist painting. And I think many of you are familiar with artists like Seurat. And I have a little collage of some of the things the students have created. So they then can take their own painting and turn it in. Now this kind of this example builds on the Impressionist, because in the Impressionist, we're putting random dots. And you only need one small change to do an Impressionist painting. Instead of just putting a random color, you have the turtle pick up the color underneath it and make a dot that's the same color as the painting. And here's an example of what that winds up looking like. We'll run it a few times and you can see it's starting to, and so really you're starting as many Snap projects do with very simple things, just randomly putting dots to make up Jason Pollock. And then by picking up the color underneath, you can then wind up with an Impressionist painting. And they love to take pictures that they've taken on vacations and turn them into these Impressionist paintings and then print out photographs of them that they share with their families and friends. So we're coming up on the end of our time, but you could follow the link to look at other details of what this involves. And we're also doing a workshop on this on, I think, Saturday afternoon. Thank you.
Thank you, Glenn. Wonderful. I love the art stuff you're doing. This is so great. Up next is Jeremy Millard, recent UC Berkeley CS grad with a presentation on Minecraft multiplayer hackathons.
Yes, thank you. I just wanted to shout out Glenn and Joe. I love the drum machine. I always love the intersection of music and coding, and it's like really cool to see that in a very physical way. So just wanted to shout that out. Hi all, my name is Jeremy. I was a student of Professor Dan at UC Berkeley. If you heard the title or my Zoom background and my kind of poorly positioned green screen here, talking about Minecraft. And specifically the Diamondfire programming platform, which I built for Minecraft. Some of you, if y'all were there last year, may remember it. Going to be focusing on kind of what has been going on with Diamondfire over the last year, and some hackathon game jam events that we've been running on the community server here. So when it comes to video games, I think you kind of need to be seen to be believed. So I have a short video for y'all that I will be sharing. All right, hoping everyone can see here. Hi all. Today I'm going to share some new developments with Diamondfire, a programming platform built on a Minecraft multiplayer environment. Some of you may remember Diamondfire from last year's SnapCon. To those of you, welcome back. On Diamondfire, players can code their own games and other concepts directly within Minecraft. Putting the coding system directly within the game allows people to use the blocks, items, and controls they are already familiar with. Both beginning and experienced Minecraft players can pick up coding on Diamondfire without prior knowledge in Java or other programming languages. In addition, the multiplayer environment allows for real-time collaboration, as well as sharing creations with others. No additional fancy server setups required. A lot's happened over the last year. We've added new coding features, such as asynchronous functions and motion vectors. We've also collaborated with popular content creators on YouTube and Twitch to help spread the word and get more Minecrafters interested in coding. Through these efforts, we've more than doubled the size of the Diamondfire community since last year. With more folks joining Diamondfire, we've seen some really cool stuff, like community-organized game jams, where players compete to create games in a short period of time. They can work in teams or go it alone, but they must build around the theme of that particular game jam. Despite these constraints and the limitations of Minecraft itself, players have created some spectacular games. In one recent game jam, we had a timed speedrunning game in a rapidly disappearing arena, a story-focused obstacle course, and many others. One excellent submission was a game called Crumble, built by a player named Jimmy. In his words, Crumble is a turn-based player versus player game where the goal is to take the flag in the middle of the board and capture it by bringing it back to one of the starting positions. Each turn, players get 3 to 5 points to spend on different actions such as moving, breaking platforms, and jumping over gaps. The board is also randomly generated to make every game unique. Jimmy also talked about going through the development process of planning, building, testing, and tons of debugging. He highlighted how he persevered to overcome the challenges, taking the game from unplayably broken to first place with a heroic last-minute debugging session. So what's next for Diamondfire? We've teamed up with Hello World Studios in Austin, Texas, to develop computer science curriculum using the Diamondfire platform. The content is directed at 9 to 13-year-olds, and we're hoping to bring it to homes and US public schools to get more young Minecraft players interested in computer science. That's a bit about Diamondfire and our recent Game Jam Hackathon events. If you'd like to take a closer look at how games are programmed on Diamondfire, be sure to catch the Minecraft game programming demo later today. Thanks, and I hope to see you then.
Woo! Boy, when I grow up, I want to be Jeremy, Millard, and Diamondfire. That kind of professional environment and community. Up next is Marnie Hill presenting CS Frontiers, Engaging Curricula for Teachers and Students. Marnie, go.
Hello, hello, hello. I'm going to go ahead and share my screen here.
Oh, you can't?
I got it.
Okay.
Gonna take a moment. There we go. All
Got it.
right. Thank you. So hi, I'm Marnie Hill, and this is an introduction to CS Frontiers, a National Science Foundation project intended to create an inclusive curriculum using NetsBlox. Okay, so here we have our senior leadership team, Tiffany, Suchi, Akash, Brian, Veronica, and myself, Marnie. So we all work together. And here we have our graduate student team who has helped us with the development of the materials and the curriculum. And finally, we have our teachers that have worked with us. They've also helped with the development of the curriculum, and they've also piloted portions of those materials in virtual camps at NC State. It's been a little difficult with COVID to kind of get the materials into the classroom, and we expect to be able to do more of that this next year. CS Frontiers' goal is to expand access for high school students to the frontiers of computing, more specifically distributed computing, Internet of Things, cybersecurity, as well as AI and machine learning. And our research is, it looks at the effectiveness of the implementation of the curriculum and as well as the impact on gender, specifically with a female experience. So currently, we have 3 of the 4 9-week curriculum modules that are completed, and we'll be completing that last module over this year and developing that to develop a full 9-week curriculum. And each module will be able to be done independently, so they don't have to scaffold one on top of the other, although there are things that are better to do first. And so we do have it in a type of order. Okay, so what kind of novice-friendly programming environmental tool will support the CS Frontiers. And of course, we have NetsBlox all over the place on the slides. I'm sure you have guessed. So fortunately for us, we have a tool at our disposal that makes these complex ideas accessible to high school learners. It's called NetsBlox. It's the brainchild of Brian Roll, who has, with his PhD advisor, Akos at Vanderbilt University, created a tool that would bring down the walls around Snap, which is a popular, of course, the popular introductory programming environment. And it enables it to embody the desired goal of a collaborative educational environment for accessible distributed computing. NetsBlox also extends the Snap block-based programming this Snap block-based programming that is used in the Beauty and Joy of Computing, a curriculum that is an AP computer science course. And so that means many high school teachers and students are already familiar with the language. And so it kind of opens up Snap to the internet, unleashing a world of possibilities. Sorry. So collaboration here is key. It's one of the great features of NetsBlox, that ability that allows students to collaborate on the same project, work together, being able to use each other's game as a game, playing each other at the same time. It's very similar to how Google Docs works. And so this is really important with the work that the curriculum that's being developed to make sure that the students have the ability to work together and collaborate. Here is an example from the distributed computing design and camp with the high school students. So we've got the curriculum, and this we piloted it with high school students during a summer camp, and this is one of the projects they created that accesses data services on the internet. So not similar, but the data access services that they access were like Google Maps, weather data, and things like that. 30 seconds. And so in my 30 seconds, I'm going to go ahead and wrap up here. We have one of our final pieces. This is an example I wanted you to take a look at. It's something that's topical, where they're charting the COVID-19 data from the Johns Hopkins database. It also shows how students can engage in data practices, not just pulling, I'm sorry, I didn't get there. Not just pulling from data, but also pre-processing and doing the visualization and working with abstractions, as well as lists and multi-dimensional data structures. I do want to also show you, if I have just a few seconds left, I want to show you how our students were able to, did it shift my screen? Are we looking at a different screen now? Do you see?
We're looking at the weather app.
You're still looking at the weather app?
Or we see day one. Yeah.
Day one, wonderful. So this right here, we actually took Google Sites and we put the curriculum into Google Sites, and we're able to set up the instructions and then put in the videos and the step-by-step guides for the students. And this particular one is on the Internet of Things. If you have any questions, because I'm sure I'm over my 30 seconds, let me go back to my slides. If you have any questions, please contact us at our website. We have csfrontiers.org, and please contact us and let us know.
Thank you, Marnie.
If Akash or Brian can answer the question that is in the chat, or if the high school curriculum is available to the public yet, I'd be happy to share it if it is.
Thank you very much, Marnie. And once again, welcome to NetsBlox Kahn 21. Be sure to also check out the keynote and all the activities about the cool ways that NetsBlox can let you interact with the real world and web services. Coming up next is Richard Millwood with, he beat me actually to that thing. He apparently does something about, I'm very curious about Vera Molnar. This has been, must be about art. Richard, go.
Thanks, Jens. Just let me put some slides up. And is that working?
I'm not seeing a slide, I'm seeing your desktop.
That's not particularly useful, is it?
Well,
sorry.
An arrangement of icons.
I've got too many choices on, and I need to stop sharing and do it again, don't I?
Maybe.
Screen. Desktop 2, maybe. Will that work?
That looks perfect.
Super. So this is really a bit of a personal journey for me. You probably gathered that I'm going to talk about Turtle Stitch a little bit, which of course is a snap derivative. But there was a certain excitement one day on Twitter when I came across a graphic. And just by the way, before I go on, tiny.cc Vera-Molnar are these slides. You can go and look at the slides separately and click on the links in them and so on at any time, even now, and you can cheat and look ahead to see what I'm going to say. Anyway, one day on Twitter, I saw this graphic you see on the right-hand side of the picture, I hope, which is the work by Vera Molnar that she created in, I think, 89. It says 89, 2004 on the website, but I think first made in 89. She made this with needles stuck into the baseboard, and then she took a 40-meter thread and wound it round the needles, visiting each cell in turn at random from point to point, and then onto the next cell, and then onto the next cell, and so on. Does that make sense? And I didn't know any of that. I only saw the graphic. And I saw the graphic without any attribution to Vera Molnar or anybody else. And I said to myself, that looks like an interesting project to try and do with Turtle Stitch, so I can make an embroidery of that. And it's only later that I actually discovered who was this all about. So you can follow up the original work there. She did this work, I think, using a computer to generate the pattern, but I'm not sure, because in the past she worked, before computers, she worked with the same kind of thinking, but using a dice to generate the randomness. Anyway, here's my project. I got on and did it, and you can see on the left-hand side how it looks on the screen, on the right-hand side how it looks on green felt when you stitch it on the embroidery machine. And I enjoyed this enormously. The key was realizing that it could be implemented on a digital embroidery machine. And then after that, it provides a challenge. This is what interests me about this, is that what art gives us is challenges to develop programming solutions and learn about programming as a result. So I'm going to just show you the code. I'm just going to quickly show you the code. I'm not going to, obviously, you're not going to read this in detail now. That's why I gave you the link to the slide, and I'll go back to that in a minute. But I tried to parameterize the code. This is really a big problem with embroidery, is you can make wonderful patterns, but they have to fit the damned embroidery frame. So it's very important to think hard about scaling, pattern size. In this case, I've got as the first variable. So I chose to do 6 by 6 cells. I just noticed now that Vera did 5 by 5, but this is a choice. Then I also had to randomize which pin do I visit next. I chose to do that by making a list of 1 to 16, numbers 1 to 16, and then shuffling that list like shuffling a deck of cards. And I'd be very interested to know what people think of this, because nobody's ever commented on my code. And then finally, I need to actually draw the cell. And here I had to start using Cartesian coordinates, not turtle geometry. because I just couldn't see how I'd do it with turtle geometry. That has been an enduring theme with Turtle Stitch, is finding out what you can do with turtle geometry, what you can do with Cartesian coordinates, and enjoying the interplay of the two. Sometimes you can do it in both ways, and you get different results, different outcomes from that, which is really, really good fun. And finally, I've got my last slide is just links, yeah? I recommend highly to anybody who's interested in Vera, go and watch this long video interview, go and click on that. Secondly, if you want to do the same kind of thing that I did, why don't you go to this interesting Python site, the next one, where admittedly the code is in Python, but you can convert that to Snap if you're a good reader of code. And can you make this rather different artwork using Turtle Stitch? Because I think that would stitch well, that one. And then I've made a link to my own project and in particular to the work I've just talked about. But I want to mention Joachim Wedekind, who's an inspiration to me because of the work he's done to recreate artworks that have been made in the past by digital artists, but recreate them using Snap. And he has some wonderful stuff to look at. And that's where I want to stop. So thank you very much, Jens.
Thank you, Richard. That was awesome.
Because that link there, TinyCC, takes you to these slides, okay? Whoops, I found myself editing the slide by mistake.
To the link. Did you ever get in touch with Vera Molnar personally? Can I ask her?
Not brave enough.
Okay, good. That's maybe we should try that at some time. Thank you so much. That was really cool. And I'm sure there will be questions afterwards. Up next is Ken Kahn from the University of Oxford with something that's a simple arithmetic with an unspeakably high number. I'm all curious what this is about. It's about encryption. So go, Ken.
So sorry, for some reason, Zoom keeps saying an error message about my video, so you won't see me, but my screen is being shared properly, right?
It is.
Yeah, good. So the simple idea here, I know what it says, but the problem is all these people's faces are showing up on top of what I'm supposed to see. Never mind. So the idea is that all you need to do is somehow turn text into a number and multiply it by your secret key. And then all you need to do to undo that is just divide by the key. So the problems are, first off, how do you turn text into a number? And the other problem is that if your key is small, like less than 1 million or 1 billion, someone could just kind of go through all of them looking for plain text. So big nums to the rescue is the answer there. So here's my little program. Maybe I'll demo it first just to give you a little funny sense of what it does. So if I say we attack at dawn or something like this, it turns we attack at dawn into a number, multiplies it by my secret key. And you could then take that number and using Unicode, just turn it into a text string with all sorts of crazy symbols in it. So that's the little demo, but the more interesting thing is how does all this work? So if I take some text, like what is a message? And by the way, the key is just any number, it doesn't really matter, but again, the bigger the better. So if I try to encode this, we get this big number. And the way this works is that you can't use 0 here, but and I am using big nums. Oh, by the way, if anybody wants to try this morning when I tried it, the big num package was broken in 6.9. So I'm in the dev version where it's working fine. All that it does is it turns the text into a number and multiplies it by the key, this integer. So how do you turn text into a number? And the idea is that you take the first letter of the text, or maybe the last, doesn't really matter what order you do it, and add that to the recursive call with the rest of the text multiplied by whatever your base is. And the base that I'm using right now is 2 to the 16th. And earlier I was using 2 to the 32nd. Doesn't really matter much what you use. So this will take any bit of text and encode it in base 65,536. And then the other direction, once you've encoded it, is you could decode it. And to decode it, you just divide by the key, whatever that integer is. And then you have to go, if you want to see it again as text, you have to reverse the process of encoding it as in Unicode. And the way we do that is we take the last letter and show that, last digit, sorry. So the idea is that I'm doing mod arithmetic to find the last digit of this base 2 to the 16th number. That's the last digit. And I'm going to take the Unicode of that and connect, and then recursively do this with the number divided by the base, which is everything but the, like in familiar decimal, that would be like the ones column, the rightmost digit. You've taken care of that, and now you've divided by, remove it, and then divide by 10, you've now got the rest of the number. So, sorry, the timer's going off. So the last little bit of this is that you could use text everywhere. Boy, sorry about the, I don't know if you're hearing it. I'm hearing this thing going off.
Slightly.
Ah, there we go. Sorry. So the last little bit I wanted to say was that first off, the text could be anything in Unicode. So here's one with some Chinese and some emoji. And if I encode it and then decode it, you get back the exact same thing, which proves that it works. And even here, you don't even need to generate a random number for your key. You could just use a phrase and turn that into a number and use that to do the encoding. So if there's 30 seconds, I got one more thing I wanted to say. I don't know how we're doing for time.
Just about closing time.
Well, so there was an interesting discussion on the Snap forum when I first released this, which was that if you use the same key multiple times, somebody could attack you by trying to figure out what's the common divisor in all the messages that you've encrypted. And I think you could just simply increment the key every time by 1. And I can't think of a way to break it, but of course there's maybe smarter people that could figure out a way to make this work for multiple messages without, some kind of attack. But it's just fun using big nums. It's fun to, I think, to use a different base than decimal. And that's what I was doing, just having fun.
Thank you, Ken. I'm going to have a close look at that myself because we'll be doing a course on encryption later this year. So we'll be taking your input there.
I should see something about releasing the screen, or is that automatically?
Probably. You can just stop sharing.
Oh, I see. Wait, yeah, got it.
Yep, great. So coming up next is Gordon Stein. Is that, I'm pronouncing it right? And Gordon is presenting something about robots driving virtual robots together with blocks.
Yep, that's exactly what the title says. So that's what I'm going to present. Yes. And you got my name right. Thank you. So I'm also with the NetsBlox group, and unfortunately we didn't coordinate, so all our talks are a little redundant today. So my, oh, you can all see my slides, right, before we continue.
We see your slides.
All right, wonderful. So I thought you were going to be seeing more of NetsBlox after this talk, but it turns out you've already seen a bit of it already. So I'm just going to give a quick overview of it again. That's sorry, what was that?
Partir. 77. Il y en avait 89.
Nathalie, you might have to mute yourself. Wait, can I mute?
Are we good now?
Yeah, we're good.
All right, wonderful. Okay, so just to reiterate about NetsBlox, it's a fork of Snap that instead of focusing a lot more, so Snap added a lot of great, like functional programming stuff and made a lot of really cool additions to block-based programming. NetsBlox focuses on distributed computing features. So you saw we can send messages between users. You can collaborate like it's Google Docs. And we also have the ability to talk to web services. So here's a Google Street View image of our lab. And we can just load this into NetsBlox. And we have so many web services and data sets that you can work with through it, all through blocks, which is very convenient for novice programmers. You also saw a little bit of this earlier, our robotics platform called RoboScape. It's a little different from the Arduino-based and I think microBlocks-based Snap derivatives, or extensions, where instead of writing code that runs directly on the robot or that is controlling it just over a wire, this all goes over the internet. It's kind of a remote control type of thing. It's robots as a web service. So you interact with this like you do when you're requesting a map from Google Maps, but instead you're saying this robot should do this. And we have a whole cybersecurity curriculum that we've run multiple years using the robot you can see on the left. It's a parallax activity bot. But recently we've had to switch to doing things virtually. So here on the left now you can see our virtual version of that same robot. And now we've built, Akos mentioned this before, this Unity-based networked environment for students to work with robots, just like they did offline. So all the same code works on the robots. It's very similar to working with them physically, other than you get a few extra features, like with the real robots, they run out of batteries, or the real robots, if it gets far away or disconnected, you can't just hit reset and have it teleport back to the start. You, in real life, have to physically carry it around, and setting up activities in real life requires us to place objects in specific spots and try to make things fair for the students between different runs of the same activity if we're doing a competition. And doing it virtually, we can guarantee consistency in all this, which is very nice.
I'll make sure it's closed whenever I leave, or when I'm playing.
Oh, so one thing to note, actually, before I move on, is that it's not limited to only a virtual version of our existing robot. We can add new robots. We've already done a few scenarios, we'll show one in a second, that don't actually use robots in the typical sense at all. But now, yeah, we can introduce new robots and new sensors to it, which will be very nice. So here you can see some of our summer camp activities. These are virtual versions of, on the left, a tug of war game we played using a robot as the rope. On the right, an obstacle course race we did. And here are two more custom environments. One has, on the right, has robots pushing boxes off of a platform they're on. They're kind of like collaborating to accomplish this task, all programmed through NetsBlox. On the left, you can see a traffic light environment we made where there's sort of a smart city intersection where the traffic lights are internet controlled, and the little blue camera looking things you can see there are traffic sensors. All this is accessible through NetsBlox through a plugin we've been writing called IoTscape, designed to enable Unity objects or any virtual object or any physical object that's internet connected to be able to be plugged into NetsBlox without having to write JavaScript code. So to wrap things up, we actually have used this in the real world already. This summer, as you saw, we ran a program using both this and our phone IoT platform that you'll be seeing, I believe, tomorrow. Students were assigned to groups and had various challenges to work with our robots and other new technology we've been working on. And in the end, they created a phone app to control the robot while it was not only being hacked by other students, but also while having to navigate through an obstacle course. And they came in without, they did come in with computer science principles, I believe, but they hadn't worked with blocks before, and most of them had not worked with robots at all, and they were all able to accomplish this task. So it was really nice for the students to to work with us and to not have to be limited by no longer being able to meet in person. So I believe that's time. So thank you for listening.
That was muted. Thank you, Gordon. Thank you very much. We're coming to the last lightning talk of this hour, and it is being delivered by our dear friend Nathalie Carrié from the island of Réunion. And Nathalie, I'm very curious about this talk. She claims that there is, she found a simple result in linear algebra playing with Brian's APL library. Go, Nathalie.
Yeah, okay. Hi, everybody. So, okay, a simple result in linear algebra found thanks to SNAP and its APL library. To generate the identity matrix of size n, you just use a reshaped block, sorry. And to generate a random matrix, you can create a block which reports a reshaped block again. And then to extract the AEG coefficient from an A matrix, you use the shaped block and you use again a iota block. Then to extract the AEG coefficient of a matrix, you just use select rows and select columns block. So you can create a block AEG coefficient, which reports the scalar value of the select rows applied to a select columns block upon matrix A, of course. And then to compute the trace, you have two ways. You can compute the trace of a matrix by the old school way, where you use a for loop block. And the other way is with this very powerful map block, where you can report a combine upon using the plus operator of a map block over the iota block, etc. To get a go factor matrix of a given matrix, you extract the matrix alpha ig obtained by removing the row number I and the column number G from A, as you see on this block, which report a scalar value and select rows upon a select columns. So we can compute now the determinant of a given matrix using a recursive formula, and this recursive formula is obtained on a very nice book, which is Algebra linéaire, matrix et réduction. It's a French book, which is very, very, very nice. And we use this formula here. So we can compute the block according to this recursive formula of the determinant, where we use the alpha AG matrix, just I show on the slide before. Then you can get the cofactor by reporting -1 at the power A plus G multiplied by the determinant of this alpha AG matrix. And then we can compute the block comatrix, which is a matrix cofactor, which report a map upon another map block over a iota block. So now, if we want to generate a square matrix, because we found a conjecture on square matrices of order n of natural integers from 1 to n squared. So you just generate such a square matrix by reporting a reshape as list, etc., upon a iota block of n product by n. So you can compute the square matrix of order n equal to 4, and you see 1, 2, 3, 4, 5, 6, 7, 8, etc., etc. So you can compute the 10 first traces of these matrices using the map block, and you have the 10 first traces of the 10 first such matrices, 1, 5, 15, etc., etc. Then we use, first of all, this square matrix for n equal to, and this is 1, 3, 2, 4. Okay, because I don't see all of my my slide. So determinant of this square matrix is obtained by the difference upon the cross product, 1 by 4 minus 3 by 2 equal -2. And if you compute the determinant of the square matrix for n in the set of natural number from 3 to 6, we find 0, 0, 0, 0. And if we map, you can get the result in one go. You can map the determinant block over a iota block. So we have this conjecture, which now is a theorem, because you have the short proof just down the side. As soon as n greater or equal to 3, the determinant of the square matrix of whose coefficients are the integers from 1 to n in the natural order is equal to 0. So a very short proof. Let's take u equal to the vector 1 to n and a equal to n and n. The matrix rows are u, a plus u, 2a plus u, etc. When we develop the determinant, in the case where n greater or equal to 3, in each term, there are at least 2u and at least 2a. Therefore, all terms are null. To get the inverse matrix, this is in the to-do list. It's not difficult with the cofactor method. You can find it in the Wikipedia. And I began to put a sprite, which is called inverse, where I began the computation. So my matrix project, you can find it, yes, of course, on Snap Cloud. My username is Nathalie. The name project is SnapCon 2021 Matrix Project. So I invite you to take the project, to make it yours, and to go further, of course, because it's just the beginning in linear algebra, and the APL library of Snap, inside Snap, gives us a lot of possibilities to go very, very far in linear algebra. And to, just for the joke, I want you to know that I found this result during a COVID contact retirement of 10 days, because it was English variant. And I get inside my house and I do some Snap to discover this APL library, and only Snap. And I had the idea to compute the determinant. So I took back my books and I worked on them, and I tried to write my little block, and I tested it. And the first result I got with a matrix I took was 27, and I was so happy to see 27, because this was the result I got when I calculated by the end the determinant of this matrix, I checked on a website which is called WIMS, where you can check your calculus, and it was a good result. So I was very happy. Then I took some other matrices, such as square matrices from 1 to n squared, and I found 0, 0, 0, 0 for n3, 4, etc., even 7, 8. I thought I had a problem with my block, and I checked.
I hate to
so
say
I
that
checked.
it must come
Okay,
to a
it's
close.
finished. It was just for the okay, for the joke, and it was, the block was not wrong because I checked further. Okay.
So it wasn't a
Finished.
bug in Brian's library. That's what we've been thinking, but it was an actual finding. How cool is that? That's amazing. I also, it reminded me why I didn't study mathematics but became a lawyer. But that's another stupid joke. Thank you very much. Everybody, thank you very much for your lightning talks. They have been lightning talks in the best, like Ignite talks, lightning talks in the best meaning of the word. We're slightly over time already. So I would like to open up for questions, but I'm afraid we're kind of out of time already. So I'll hand over to Michael for another announcement.